During the early Apollo years, NASA scientists and engineers anticipated the need for a vehicle to aid the astronauts in exploring the moon. It was expected that bulky spacesuits, limited life supplies, and other inherent weaknesses would decrease man's mobility on the lunar surface. In 1964, with conceptual design of the Mobile Laboratory, or MOLAB, NASA began research on lunar surface vehicles. Over the next few years, an entire spectrum of vehicles was designed and studied. From these efforts came the knowledge that contributed directly to the development of the lunar roving vehicle. Its development required solution of many challenging technical problems for which there were no precedents in terrestrial vehicle design and operation. For example, the lack of an atmosphere on the moon, the extremes of surface temperatures, plus or minus 250 degrees Fahrenheit, the very weak gravity, 1/6 of Earth's, and the many unknowns associated with the lunar soil and topography. All these factors imposed severe and unique requirements on the LRV. The first manned landing on the moon, Apollo 11, and subsequent missions confirmed the long-recognized need for a lunar vehicle, a vehicle which would allow astronauts to cover more area, to conserve energy and life support materials, to transport additional equipment, and to return with more lunar soil samples. For even before these practical demonstrations, in May of 1969, NASA decided to proceed with the design and development of a lunar roving vehicle. The Marshall Space Flight Center at Huntsville, Alabama, where the Saturn V moon rocket had been developed, was assigned overall direction of the LRV program. Prime contractor was the Boeing Company, using facilities at Huntsville and Kent, Washington. Major subcontractor was GM's Delco Electronics Division in California. The LRV would be a two-man, four-wheeled vehicle, 10 feet 2 inches long, 44 inches high, with a 7.5-foot wheelbase, weighing 460 pounds Earth weight, and capable of carrying a total payload of 1,080 pounds. The LRV would have 5 major systems: mobility, cruise station, navigation, power, and thermal control. The mobility system, which must be able to cross 12-inch high obstacles and 28-inch diameter craters, consists of the wheels, traction drive, suspension, steering, and drive control electronics. The system was designed, developed, and tested by General Motors. The first assemblies were put through development tests to measure strength, deflection, endurance, and other factors. For example, driven on a rolling road fixture, the wheel assembly was tested under Earth conditions, and later in test chambers reproducing the environmental conditions of the moon. The LRV tires are made of a woven mesh of zinc-coated piano wire, to which titanium threads are riveted in a chevron pattern to keep the wheels from sinking into the soft lunar soil. Long-duration torture testing on this so-called carousel, simulating the lunar surface, verified the durability of the wheel design. The test assembly was supported by springs to relieve most of its weight, thus simulating the 1/6 gravity of the moon.